Hello children, welcome to the online class. In the previous lecture I discussed about conduction through a conductor, means how does conduction take place through a conductor with the help of free electrons and external source of EMF. Today I am going to discuss about drift velocity, drift speed. The idea of drift velocity and drift speed was also discussed in the previous lecture. So let us start with drift speed, drift velocity. As I discussed in the previous class, that when we cause a potential difference across a conductor, free electrons start moving, start drifting from negative end to the positive end of the conductor. The average velocity of these free electrons is called drift velocity. So you can write the definition of drift velocity. It is the average velocity of free electrons through which they drift from negative to the positive end of a conductor under the effect of potential difference across it. So this is the definition of drift speed. Now I will find the expression for drift speed. Suppose here is a conductor, conducting specimen, and it has n free electrons. They are drifting from negative to positive end of the conductor. Means suppose this is the negative end, this is the positive end of the conductor. So free electrons are drifting from negative to positive end of the conductor. When there is no potential difference across the conductor, the velocities with which free electrons were moving are called thermal velocities. So let us start from there, that when there is no potential difference across the conductor, n free electrons are moving with thermal velocities u1, u2 and un respectively. Means u1, u2, un be the thermal velocities with which free electrons are in random motion. So their average value is 0. You already learned this fact, this concept in the previous lecture. Now whenever we cause a potential difference across the conductor, there is an electric field set up inside the conductor. Suppose that electric field is E. And you know electric field is from positive to negative end, So direction of electric field is from positive to negative end. And electrons are negatively charged. Particles, you know, force on a charged particle in a uniform electric field is given by F is equal to QE. This is the force on a charged particle in a uniform electric field carrying a charge Q. The charge on an electron is minus E. So this force on a free electron is minus EE. Got it? If m be the mass of free electron, then the acceleration produced in each of the free electron will be given by A is equal to F by m, force by mass, and force is minus EE by mass. So this is the acceleration caused in each of the free electrons under the effect of the external electric field E. Is it clear? So each and every electron, free electron, will start accelerating towards the positive end of the conductor, and they start with initial velocities u1, u2 and un. Suppose an electron, a free electron, starts with velocity u1, which is thermal velocity, and collide an atom after time small t1. Okay, so what will be the velocity with which it will collide? So let n free electrons undergo their collision in time tau 1, tau 2 and tau n respectively. Then their velocities, means velocities with which they collide in time tau 1, is given by v1 is equal to v is equal to u plus at. So this is u1 plus a tau 1. You see a is same for all. This is for first electron, first free electron. For second free electron, this is v2 is equal to u2 plus a tau 2. In the same way, each free electron will collide with velocity v1, v2 and here vn, un plus a tau n. You see v1, v2, vn be the velocities of free electrons, okay, with which they collide, they move. So the average of these velocities is called drift velocity. Therefore, drift velocity is given by drift velocity of free electrons, velocity of free electrons is given by Vd. This is average of v1, v2, vn. v1 plus v2 plus vn by n. Got it? You see v1 is u1 plus a tau 1, v2 is u2 plus a tau 2, vn is un plus a tau n. So you can write it u1 plus u2 plus un by n plus a common tau 1 plus tau 2 plus tau n by n. Can you write like this? Now see, u1 plus u2 plus un by n is 0. Here it is 0. So this term will be 0 and you will have a tau 1 plus tau 2 plus tau n by n, and this will become a tau, where this tau is equal to tau 1 plus tau 2 tau n by n is the average time between two consecutive collisions of free electron called relaxation time. You see, why is it called relaxation time? You know, relax. So the time between two consecutive collisions, electrons remain relaxed. Hence this time interval is called relaxation time. Got it? So it is relaxation time. Now you can write it from here, Vd is equal to A, and you know A is equal to minus E by M. So you put the value minus E by M into tau. This is the expression for drift velocity of free electrons through a conductor. Now you see, this is with negative sign. Here Vd is a vector and E is a vector, and negative sign is with E. What does it mean? It means Vd is opposite to E. Okay, and electric field is from positive to negative end of the conductor. So drift velocity will be from negative to positive end of the conductor, and you already know free electrons move from negative to positive end of the conductor. Hence electrons drift from negative to positive end of the conductor with this velocity Vd is equal to minus E by M into tau, and this helps free electrons to constitute electric current. What does it mean? It means this drift velocity is related to electric current. Hence we can find the relationship between